design project. This is December the 13th, 1995. This is the third of four groups that will be presenting today. What's the name of our group? Automation Trendsetters. Automation Trendsetters will be next making the presentation. And they will be presenting their conceptual design with their models that describe their engineering concepts.
Okay, first of all, I want to introduce everyone. We are Automation Trendsetters, and this is Robert Baker. I'm Catherine Briley. This is Mark Hoffer. That's Jason Johnson, Cynthia Wada, and Chad Whitmire. Basically, we're going to give you an introduction of our conceptual designs. Our problem statement, basically we came up with a system that that presents a panel. It makes a loop, it inserts a loop, and then it cuts it at the very end. Next. And then these are our goals, or our customer requirements. It should meet all OSHA requirements. There should be an increase in production. It should be easy to switch styles and must handle various fabrics. It should be efficient, economically viable, and accurate. And next we're going to discuss the three components of our design. So next slide. The concepts, first one is the panel feeding and positioning. The second one is the loop assembly, and the third one is loop insertion. And Jason Johnson and I are going to present the panel feeding and positioning. So next slide. The feeding and positioning, the three components are the panel transport, panel alignment, and folding and shedding. Okay, and then this is our panel transport. It's going to be made up of 3 belts, and the reason for that is just to be more cost efficient. It'll be less expensive than just one. And also using the 3 belts, it'll have less damage to the fabric because of the smooth areas right in here. And it's going to be controlled by one motor, and that'll make sure the fabric won't migrate to the side. And then in this, there's going to be a sensor that senses the panel coming in, and the sensor will set off a timer, and the timer will start the loop making process. Next slide. And here's Jason.
All right, we'll talk about the panel alignment and the folding mechanism for the fabric position. Basically, we utilize 2 cone devices to position the fabric so that we can keep it aligned towards the side that enters the sewing machine. Basically, we have the velocity of this side of the roller as the panel starts to shift from side to side. You can increase each of these rollers, the speeds, based on 2 incremental motors. As this side starts to shift, and I'll show you this in our feasibility section of our presentation. This side starts to shift. This conical roller can increase the speed, thus shifting it back into position. Next slide. This is our folding and shedding diagram. Basically, for the folder, we utilize 2 belt systems, one here and here. This belt right here starts the fold as it goes through the folder. This belt here continues to migrate the fabric forward under the sewing machine. The band material is going to be inserted from the bottom. This is because the sewing machine that we have now is the face stitch is on the top, therefore the good side should be on the top and the band material should be on the bottom. This allows an opening here that the loop can be inserted, as Cynthia will show you. Next slide. All right, these are our feasibility tests. Basically, we laid the panel on 2 sets of belts to show that the weight of the fabric can keep it supported as the belts will pull the fabric along a smooth surface. All right, the next slide. This is an example of our positioning system. As you see here, this edge is not aligned, and it's important to have an aligned edge as it enters the sewing machine because accurate loop placement is necessary. This cone And this cone right here can be moved and shift the panel over to the side. And if it's in this position, this cone here will move and shift the panel back this way. All right, next slide. This is an example of our loop folder. Basically what we did, we utilized two belts, as I said before. The first belt here begins to fold across the table. This is the picture of both belts. The second belt, you can see it moves the fabric along underneath the sewing machine. So, and that's next. The next part is going to be the loop maker and rods. That's just another example of how the shed's going to be working. The band material is coming in from the bottom. This is the fabric panel. This is how the loop's going to be inserted so that there's a space that the loop can be inserted.
Okay, what we're doing here is I'm just going to try to introduce you to the major components of our loop maker, and then Robert will go through the actual operation of it. Basically what we have are we have 3 air cylinders. One air cylinder for a cutter, another air cylinder, this will be the loop former, and this air cylinder will be to come down and grip the fabric. It consists of 2 control rolls, which can be tensioned, and it consists of 2 spring-loaded rolls, which will hold the loop in the nip after it's formed. And basically we have 3 steps, which are initiation, formation, and termination, which Rob will explain to you now.
Okay, we go through step by step with this. This is where it'll be when the operator will load the loop material between these 2 rolls. Then we'll turn it on, and this top air cylinder will extend down, and the gripper will grip the top of that loop fabric. The next step, it'll pull it right back up. Okay, and that's where we are here. That'll start the process of forming the loop. As you can see, the 2 spring-loaded rollers are spread apart, allowing the middle roller to pull through with the fabric. And it'll continue, and they'll clamp back down and keep pulling. And this will be fixed, but the loop fabric will keep coming through here. Next slide. Okay, and that's where we are here again. It'll keep pulling. At this time, it'll let go at the gripper, and it'll cut right here. And it'll continue to pull so that the 2 ends are even, and then it'll be ready to be inserted into the panel. And then here's Chad again for the feasibility.
All right, here's what we have for our feasibility test. I spoke before the control rolls. What we want to make sure of is that the loop material could be either taken off of a roll, which currently not, or out of a box. Now, our main concern coming out of the box, as you can see, the material is tangled and twisted, and we wanted to make sure as it came through the control rolls that it wouldn't stay that way. We wanted to be able to take out any twist and maintain the seam of the loop material on one side. And as you can see, basically these we made these static. We didn't roll them, but we pulled numerous feet or several feet through the rollers and maintained a good tension, and it was very straight. The second thing we did was we wanted to see if we needed to make the spring-loaded rollers, if we needed to make those fixed or give them the ability to roll along with the loading. And this is our feasibility test here. We took 2 small diameter rollers and took another smaller diameter shaft and basically tested how hard or difficult it was to pull through 2 loaded rollers. And this, further testing has to be done here to determine spring constants and things like that. And this here, what we were testing is when you can hold the fabric and still have fabric pass underneath. That was our feasibility test there of how effective the gripper would be as a greater or more loop material was pulling underneath. Next slide. And then this is Mark Hoffman and Cindy Waters insertion.
Hi, Cindy. Basically, for the loop insertion, we have a rail system and a gripper, which grips the loop right from behind the press rollers where the loop assembly is made, and it brings it, on this model you can see, it brings it from the loop assembly over to where the shed will be, the fabric shed, and it'll be inserted in right there. The gripper will have an electromagnetic, the gripper's not on this model, but it'll have an electromagnetic opening for the gripper, which we can control with the PLC. And this is the rail positioning system. The rail positioning system will also have a pneumatic cylinder on it so that we can lift it, the gripper above where the loop will be so that it can clear the fabric without damaging it and get it in place correctly so that it can pick up the loop and insert it. This is the where the tab will go, the band. We cut out a little piece of the table, and it's going to be the exact size of the band so that the band will not move, and it just guides it in, and that way you'll have a straight line with your band to your fold-over panel. And now Mark's going to tell you a little bit more about the system.
Okay. First thing I'd like to point out is we went through several different ideas on how to insert the loop after it was made, and with Rob's model, if you can kind of position it, what's going to happen is the gripper is spring loaded so that it'd be normally closed. And what's going to happen is when the gripper, we hit it with an electromagnet that will lift it up and then grab it here. And then once that occurs, what's going to happen is this pneumatic cylinder or this rotating pneumatic is going to push this all the way around. Now the trick that we have that we need to do more testing with is to determine how fast we need this to turn to keep it at the same speed, because the goal is to get it up to speed with how fast the fabric will be moving. The goal in this is to keep this as a continuous operation. We had flip-flop back and forth with the idea of possibly having an intermittent and having different steps involved. But where we stand now, we're going to have a continuous system where this is going to be able to swing back and forth. And the pneumatic cylinder, the trick that we had was that whenever this came back, we were afraid that with the loop maker, what was going to happen is that the gripper was going to bump into the material and push it out of the way or cause deformation. So what we decided to do was to have this air cylinder that would raise the entire track approximately 3/4 of an inch to clear where the gripper is here. That way we don't have any problems with it bumping. And then as I say, it will pull it away. The next slide will show maybe a little bit better and put this model together with that. The track that we've shown here, this is a single track, but the way we like to see it is to have a bearing that would ride in between two tracks and be able to move through with some type of lubricant that we're going to work with to make it move smoothly along those lines. And with that, does anybody have any questions?
Back up a little bit. Yeah, just because the video is focusing. The video's looking at everybody. Move in just a little bit more here. Your rotating pneumatic, that radius is not constant, or is it?
No, it won't be constant.
Okay.
It'll change.
Okay. All right. What you've got basically a torque to turn it. How does that radius change in terms of the driver?
Okay, if this is the driver,
All right.
there'll be a slot here. So if it needs to, when it turns, it'll be able to push through and forth. So it'll have an excess on the shaft that runs. On this shaft, we'll have a bit of an excess back here, so that when the radius does shorten in this region, as you can see, this region, the radius is a bit shorter than here, that excess will be able to push back through, so it'll be slotted.
The height, roughly the height from the top of the rail to the gripper is roughly how many inches? Based on, is that model fairly
Yeah,
accurate
the
there?
inside of it's right. The inside of that
I would
model's
say it's
right.
about 3 3 inches.
Okay.
We want the gripper just to go right above the table.
Right, okay. So it actually will not touch the table.
Correct.
It's just gonna be down and it's gonna glide along.
Okay. Now, how will the gripper take the loop out of the rolls? You'll have a electromagnet to raise the spring-loaded rolls up to release it?
I believe the spring-loaded rolls are gonna be positioned in such a way that it's gonna pull them out from the side. It's
Gonna
gonna
pull it out.
Yeah, it's gonna pull it out from the side, so hopefully we're gonna relieve the pressure there, or it's gonna be at a point where the pressure is at a minimum, so we can pull it out from the side, and there'll be nothing there that will hinder it going around.
I think that if we set it at the spring constant right there, that it'll be enough to hold that end of the loop. I don't think it's gonna take very much at all, and that shouldn't be any problem to come in there and just pull it out.
Will the clamp go behind the rollers or in front? You know what I mean?
Yes, sir. Just, all right, this will be positioned, the sewing machine will be coming out this way, and the arm will actually come in here and grab it and go in.
Okay.
That's the way we're looking at it. Now, these 2 rolls, like I said, I think, actually, you see where I moved the model because the way we had it, there was a bar there. So we're gonna have, so there's nothing in the way, and I really think that that'll hold that end of the loop without a problem. And as it's pulling the loop off, it'll actually pull it off of this puller back here. It'll actually pull it away
Right,
from it
right.
instead of pulling against it.
Right,
So
so
I
I was
think
just
that'll-
concerned about distorting that half inch or so that
Yeah.
at some angle, so that if you had to actually have that, a pneumatically actuated pressure, you could raise that cylinder if you needed to.
Another thing we're working on a great deal is dimensioning, and we're still working with the dimensioning of the roller, and that's mostly to compensate for the smallest loop. The largest loop is not really the problem,
Right.
it's the smallest loop.
Let's go back. Questions? On the,
Yeah, I was hoping you'd have questions on the position.
well, that was, okay, yeah, talk about the position.
Could we go back to that slide, if possible? It's just, if you keep going back and back. You'll see some cone-shaped rolls. Just.
Mhm. It's toward the beginning. It's just taking a little time.
Okay, well, right there, stop there. I had a question about that. Oh, okay. Now, follow the belt. That, the belt that's underneath, it's in between the wood and the
The blue fabric.
bottom? Yeah. So where does that belt go?
It goes,
This, what are we talking about, this?
the black belt, it goes in
Right,
between the
this right
2
here.
needles on the chain stitch machine.
This right here is symbolizing the folder. That,
Okay, but is there a belt there at all?
yeah, there'll be a belt up above, which comes
A
in
belt
right
above.
there. There's a
Okay,
drawing.
there wasn't-
There's a drawing.
Okay, there was a belt. You got one belt to do the initial fold and one belt to hold it in place.
That's bad.
All right, that's okay. We don't have to go back. I understand that. So basically, you got the fabric, you've got an edge, and you got the belt underneath with the half-inch fold underneath. Where does that belt stop?
Approximately right in here.
Okay, that's what I was
It
asking.
doesn't go all the way to the completion of the folder. It doesn't go all the way to the folder's end. But what it's there for is to that folded edge, it's there to make sure that it stays the same velocity as the top fabric.
Right.
That way it doesn't have a an odd angle with the edge of the fabric.
Okay,
when it
all
goes
right, 'cause
into
when I looked at that, it looked like the belt may continue, and I was wondering where it turned back.
So then-
Yeah.
Right.
If you keep going up, we'll get to that drawing, you might be able to see it a little better
Okay.
on the.
So right there, you can just have the folder.
Yeah.
Okay.
And see, this is sort of a
Right.
large scale of what would be inside.
So I was following that belt.
Yeah. And then there's the positioning.
Okay, now let's just stop right there for a second. Go back to the operator placing that panel on the table. Okay, that's placed on the movable, okay. And, she does what I call the general alignment, and this does the fine tuning as it moves through there. Do you still have belts underneath?
At this point, no. Or the belt here would be probably right under here, close to the edge of the fabric,
And see,
as far as the
okay,
position.
my question there is that if, I don't know how big, I know you got those cones are used
Yeah,
for
it's-
examples, but
yeah.
in terms of the physical size,
Yeah.
if they're not directly over the belt, you could get some, all of a sudden, when they do their thing, they could stop the fabric or distort the fabric, or you get sliding.
Basically, the idea here is to have these continuously rolling. And what they're going to do, having a larger surface velocity here than here, is create a tenor effect on the fabric. And the way we're going to determine the length of these rolls is by deformation of the fabric in basically force per linear inch.
So what you're,
From the figures-
what you're
the
saying
figures
is
that we
that
have.
you would have both these rolls turning at sufficient velocity from a vector standpoint to be moving
This, yeah.
the fabric in this direction. It's gonna wanna be moving the fabric in this
Right.
direction if you're
You-
moving
you
the
go up
same.
more- We get to the AutoCAD drawing, you might be able to see this a little bit better. Okay, keep I'm not sure exactly where it's at. Okay, so this was the,
Right, okay.
the belt
Now,
stopping here.
all right, I see it now. And then you've got a folder that, or a plate or something that holds that underneath, that holds that fold in place. Okay.
Yeah, it goes and it curls under.
Okay,
underneath.
all right, I got it.
Okay, and then up.
Go back.
Yeah, now here will be your sort of your vector type
Alright.
analysis. And basically in the report, the angle, this angle will have to be determined experimentally,
Okay.
depending on how much the fabric will stretch. The more we pull it this way, the less stretch it'll put on the fabric between here and here.
Right.
The less it'll push it out. And basically we brought some fabric here, just to kind of show, basically as it's fitted in. Yeah, it might be kind of tough. Like, say if this is the line right here, as it's fitted in, these rolls create kind of a tenor effect as it's pulling through. And if you increase this roller, it'll go this way. If you increase this roller, it'll go this way. And so if you keep the velocities relative, you can increase or decrease either roll. And theoretically keep the same tenor effect. Because basically when the operator's sewing the panel, she's keeping a tension on it this way. And she's also keeping a tension on it this way as it's going into the folder, into the machine. And that's the basic idea behind the conical design.
Yeah. That's real innovative. I don't know if that's what we want. I mean, in terms, I don't know how, and that's what you're saying, experimentally, we don't know how much stretch we want to put on it.
Right,
Okay?
and then hopefully, from going from these angles, the greater the angle is, so if you take a perpendicular to the panel, the greater this angle is with that perpendicular, the more tenor effect you'll get,
Right.
depending on surface friction as the fabric goes through.
Right.
So, we'd have to make that either make it a good angle for all four fabrics, or make it easily adjustable.
Okay. And, okay, so the way you're going to control this differential speed is based on what?
It would be based on where the edge is.
Okay.
So we'll keep, yeah, so
Okay,
we'll-
so
what we'll try to do is keep a tension between, this is, if you were the needle looking at the rolls, this is what you would see up top. And so basically, you'd see the fabric
So
trying to
you're not,
come back
okay,
in.
you're based, all right, you got, he's trying to get the scale is throwing me off here. Are these really gonna be about like so, or
Yeah,
about,
it's,
you know,
I've
I'm
looked at,
trying to get a,
yeah, we've looked at the figures,
now when you say needles, if you were to
the
put.
sewing machine, yeah.
Yeah, I know that, but you're gonna have, you got two, it's a double needle machine.
Right.
All right, is the needles basically gonna be located on the outside edges?
Yeah, it'd be over here.
Okay, where would two needles be?
These would be behind the folder.
Right, certainly, I understand that, but in,
Two needles
And
would
the
be coming
needles,
down right
the
here.
needles, yeah, the needles would be over here.
okay, two needles, okay, I got you.
Like,
Okay, I see. Okay, that's neat. If I can talk to you about some things that I've seen, basically, they did something similar with trying to automatically feed in, doing the fail steam for jeans. The idea was toothpaste caps, basically in kind of going parallel with it, because it's got slide, but the ridges, so if you turn the caps, you can move the fabric back and forth. It's kind of like taking one cone in line,
This way.
like that. It's got ridges such that the coefficient of friction in this direction, it slides. But if you turn it, the ridges are like teeth that push it back and forth. So, I mean, but this is, I mean, I like the concept.
Yeah, and hopefully like on the initial between these and the belts, we'll be able to get that good initial fold and initial edge through.
And I like the folder, that looks really good because, and, just for your information, the group asked me, could they feed it from the bottom? And I said it would be a great addition from your standpoint. They asked if they could do that. and
Well,
I-
really, it's great for us because if, true with chain stitch, you want to come from the bottom, but even if we go to lock stitch, it doesn't matter.
You don't make any
We
difference.
still come from the bottom.
Yeah, one thing that Rob came up with at that time was that, also just the fabric going off the table, gravity would help us out with the fold.
Yeah. So anyway, that's something that I approve and that I go full force with it. So,
I really like that idea because like I said, other people that help us, either way we go, that's
okay.
a good answer for us.
Okay.
Really.
So,
Yeah, and then here's Cynthia model, the feed.
right.
And the shed will basically be up like this.
Okay. Once you get into that, make sure that in terms of that incline and angle, we don't interfere with the mechanisms underneath. And I'm sure you've got the machines to look
Well,
at
what we
there.
can also do is put a hinge on it so you can bring it up and get
What?
underneath to when you have to replug the machine.
And the,
Just make it surface.
You should have the band folders when you come back from the holidays. We sent out samples of how made, and they lost the samples, and then they didn't bother to call us and tell us. We called to check on the folders, and we never got your sample.
It was sent.
And we sent samples 4 times.
Last time was.
Who's doing your folder?
New York sold.
New York Soul.
Last time was 4 times we sent samples. We should have them when you come back from the holidays.
Okay, good job. I don't have any more questions. The next phase is building. Start thinking about it. I know you've already begun thinking about it in terms of something that's just from a design standpoint, that from experience, students tend to overlook